Hello and welcome to this section of Calculus Extra Practice with Integration. Here we're going to continue and conclude our discussion on integration by parts by leaving you kind of with a granddaddy problem. It's not really difficult once you know how to do it, but I will tell you that when I was taking calculus the first time, I would never in a million years have guessed to do a problem like this in this fashion. But once you know the trick, it's something that kind of sticks with you and you can just kind of use it over and over again as you see fit. And it's something that's not that hard to do once you get the hang of. So the problem that lends itself to this is integral e to the negative x times cosine of x dx. Now when you inspect this carefully, you get a little bit worried because you see that I have an indestructible function times another indestructible function. Either one of these guys, if I keep taking derivatives over and over again, they never disappear. So immediately I start worrying that maybe I shouldn't even use integration by parts here. Because I kind of told you the general form is destructible times indestructible, and that's true, but this is a special form of a problem, and this isn't the only integral you can use this for. It's just anytime you have two things that are kind of indestructible times indestructible and you're trying to integrate it, a lot of times you can make this guy work. Now rather than just sort of explain what to do and kind of give you a big picture, it's going to be impossible for you to follow that. We just need to solve this problem just as if we were going to do it like normal. So let's go ahead and do integration by parts. You have to trust me a little bit that the integration by parts is the way to go. Now we have to choose a u, and what we're going to do is choose u is equal to e to the minus x, and dv will have everything else in the integral, cosine of x dx. All right, so you want to choose this guy, and we know that it's not indestructible. We know if we keep taking derivatives of this, it's not going to disappear. So in the back of our mind, we're a little bit worried. But, we'll just deal with it and see what happens. So take the derivative of this. So what we'll have is du dx is e to the negative x, because it's indestructible, times the derivative of the exponent, which is just negative 1. That's the derivative of the exponent there. So then du, which is really what we want, is negative e to the negative x dx. That's what we're after. And so what we have here is we have u, and we have du. It didn't get indestructible, it didn't disappear, but we've done it correctly. And then over here, v is the integral of cosine of x dx. So v is, what's the integral of cosine? It's the sine of x. And so that part was pretty easy. So now we have v and dv. All right, so we suspect integration by parts is going to be useful. We're a little bit worried about what's going on here, but let's go ahead and put it all in and see where we get. So we have u times v minus the integral of v times du. U is e to the minus x. This is a minus x. Make sure you can read the minus sign up there. Times v, which is sine of x, minus the integral of v, which is the sine of x, times du. Du is negative e to the negative x dx. So that does not look simpler. But let's go ahead and simplify and tidy things up a little bit and see what happens. We have e to the minus x times the sine of x. We have negative times negative is positive, so that's good. And then we have the integral inside. We have e to the minus x times the sine of x dx. So what we have is e to the minus x sine of x plus this integral, and we ask ourselves, is this integral simpler than what we got the first time? We compare it looking from here to here, and I honestly cannot tell you that it's any simpler because we still have the e to the minus x, and instead of a cosine, we have a sine. So your first thought, if I didn't